चैप्टर्स एंड किए। सो आज के लेक्चर में हम नया चैप्टर स्टार्ट करेंगे, दैट इज नथिंग बट योर प्रोबेबिलिटी। Probability, right? So what do you mean by probability? So basically probability हम किसे बोलते हैं? In general life, probability means in general आप बोलते हैं ना, probably आ भी सकते हैं, नहीं भी आ सकते। अभी गेस्ट आने वाले हैं बोल के समझो आपके घर को, तो प्रोबेबली क्या है, आज आ भी सकते हैं, कुछ काम की वजह से वो कल भी आ सकते हैं। प्रोबेबली वी कैन से, एग्जैक्टली वी कांट से। आ भी सकते हैं कि नहीं भी आ सकते। पॉसिबिलिटी क्या है यहाँ पे, दोनों हो सकते हैं, एक आ भी सकते हैं और एक नहीं आ भी सकते हैं। इन जनरल इट इज राइट। तो सिमिलरली इन मैथमेटिकल लैंग्वेज प्रोबेबिलिटी इज नथिंग बट the outcomes, we can say the experiment what we are doing, an experiment in which the result will not be essentially same। एक ही रिजल्ट नहीं रहेगा, इधर वो एस भी रहेगा, इधर वो नो भी रहेगा, राइट। पॉसिबिलिटीज जितने भी है, अभी क्या है, बैटिंग कर रहे बोल के समझा, वीरेंद्र सहवाग बैटिंग कर रहे, इंडियन क्रिकेट टीम के प्लेयर है। अभी वीरेंद्र सहवाग बैटिंग कर रहे बोल के समझो, फॉर एग्जाम्पल अभी आने वाले बॉल को वो 6 भी मार सकते हैं, 4 भी मार सकते हैं, या 2 रन, 3 रन, 1 रन ले सकते हैं, या डक 0 भी हो सकता है, विकेट भी जा सकता है, कैच आउट हो सकते हैं, स्टंप आउट हो सकते हैं, रन आउट हो सकते हैं, कुछ भी हो सकता है। तो प्रोबेबिलिटी क्या है हमारा, कुछ भी हो सकते हैं। वी कैन नॉट प्रेडिक्ट इन एडवांस, एग्जैक्टली हम बोल नहीं सकते प्रोबेबिलिटी, राइट। सो प्रोबेबली समथिंग विल चेंजेस, कुछ ना कुछ चेंज होते रहता है, उसे हम क्या बोलते हैं, प्रोबेबिलिटी बोलते हैं, राइट। सो लेट्स सी। So in our previous section we have studied the definition of probability through classical approach, right, and empirical approach also. So in this chapter probability, we shall define the axiomatic approach of probability. But let us first define, to explain various terms which are used in the definition of axiomatic approach to probability using sets. तो प्रोबेबिलिटी स्टार्ट करने से पहले हमें कुछ डेफिनेशंस मालूम रहना चाहिए, कौन से टर्म्स हम यूज करते हैं प्रोबेबिलिटी में टू डिफाइन एन एक्सपेरिमेंट और अ सेट और एन ऑक्सियोमेटिक अप्रोच टू प्रोबेबिलिटी यूजिंग सेट्स। सो लेट्स सी फर्स्ट इवेंट, और यू कैन से फर्स्ट term what we are going to study is random experiment. What is random experiment? Yes, random means कौन सा भी, you can choose anyone random, right? Experiment means it's a process, step by step process. Experiment is nothing but step by process, right? So random experiment is nothing but an experiment in which, let's see, an experiment in which results, or you can say outcomes also, you can say outcomes will not be essentially the same, essentially the same, even under homogeneous and identical conditions. Such experiments are called random experiment. random experiment, right? So random experiment is here an experiment in which the result, or you can say the outcomes, will not be essentially the same even under homogeneous or identical conditions. Such experiment, what we can say, it's a random experiment. For example, let's see, for example, tossing a coin. First, tossing a coin. So when you toss a coin, for example, 1 rupee coin you have, so you are tossing a coin, so you cannot predict exactly either it is head or it is tail, right? So the random experiment is what here, either it may be head or tail when you are tossing once, right? So what we get here, sample, random experiment sample means random experiment is nothing but, for example, what we get head or tail also when we are tossing a coin once, right? So next, rolling a die. Second one example, rolling a die, right? A die means it has 8 faces, right? Already you know. When you are in a childhood, I think you played this game, rolling a die. What you can say, that is chamma, you can say, right? The rolling a die, the subsidy. By rolling a die, you can play like this, right? So rolling a die is also, it's a random experiment. So in that we get random experiment number of outcomes. Either it may be 1, 2, 3, 4, 5, 6. Total there are 6 faces, right? And next, drawing drawing a card from a card from a well shuffled pack of cards, etc. Nothing but what? Random experiments. Random experiments. So in detail we can see this for tossing a coin. Let's see for first example, that is, suppose we toss a coin, right? So the of the experiment result of the experiment is that the coin may fall either the coin may fall either tail, denoted by what, capital T, or head, denoted by H. Is one of the element of the set is what? One of the element of set is nothing but head or tail, it is, right? So next, second one for die, rolling a die. So now consider a die. Consider a die means you have 6 faces. So like this, the die is like this, right? So total you have what? 1, 2, 3. This is 4, right? 1, 2, 3, 4. And this side 5. and the back side is 6, right? Total 6 faces we have a die. So a cube with the 6 faces marked, a cube with 6 faces marked successively with 1 to 6, right? 1 to 6 dots. When a die is thrown, result of experiment is that die may fall uppermost with face marked with 1, 2 or 6. That is one of the number of the set, that is 1, 2, 3, 4, 5, 6. Totally there are 6 faces and a 6 dotted line on the cube. So when you throw the die, so when it is fall down at the time, it may be uppermost, either it may be 1, 2, 3, 4, 5 or 6. There are 6 outcomes, possibilities are there. So next, finally, third one more we will take. When a coin is tossing twice, suppose if we toss a coin twice, if we toss a coin once, means we can head or tail, two possibilities. So when a coin toss twice, so the result of the experiment can be indicated. The result can be indicated by the set of ordered pair, that is nothing but H, that is head head, head tail, tail head, tail tail, right? So it is nothing but head in the first toss and head in the second toss, head in the first toss and tail in the second toss, it is tail. So tail, head, tail, tail. So for the convenience of the order pair, HS is briefly denoted as double H, etc. So the result of the experiment is what? The set HH, what we can write it as HH, HT, TH, TT, right? So it is nothing but when a coin is tossed twice, the possible outcomes are 4, right? So the number of possible outcomes is 6. So in the first, the possible outcomes are what? When a coin is tossed once, the number of possibilities are what? Only 2 possibilities we have here, right? So these are what? A random experiment. So next, we'll move the sample space. Next heading is what? Sample space. Let's see what is sample space here. A set yes, which consists of all possible outcomes of a random experiment is called a sample space. तो किसे बोलते हैं sample space? A set, yes, usually sample space capital S से denote करते हैं, and which what it consists? The set consists all possible outcomes of a random experiment. अभी हमने random experiment देखा, वो पूरे जितने भी रैंडम एक्सपेरिमेंट के आउटकम्स रहेंगे वो पूरे एक सेट में लिखे तो क्या होगा, वो हमारा सैंपल स्पेस होगा, राइट. सो ईच आउटकम इज कॉल्ड एंड ईच आउटकम इज कॉल्ड सैंपल पॉइंट, राइट. सो एक एक आउटकम है. फॉर एग्जांपल टॉसिंग अ कॉइन, उसमें क्या है, एक बार कॉइन इज टॉसिंग वंस बोल के बोले हमने, तो टू पॉसिबिलिटीज है वहाँ पे, एक हेड और टेल है. तो हेड को क्या बोल सकते हैं हम वहाँ पे, सैंपल पॉइंट बोल के बोल सकते हैं. टोटल हेड और टेल को क्या बोल सकते हैं हम उसको, सैंपल स्पेस बोल के बोल सकते हैं, राइट. सो एस करस्पॉन्ड टू यूनिवर्सल सेट. यहाँ पे एस क्या है, हियर एस करस्पॉन्ड्स टू व्हाट, यूनिवर्सल. ऑलरेडी यूनिवर्सल पढ़े आपने. यूनिवर्सल सेट क्या है, इसमें पूरे सेट्स आ जाते हैं. यूनिवर्सल सेट, right, which consists all the sets. Thus the sample space, yes, in each of the above examples are given by, let's see, first example, it is yes equals to h comma t when a coin is tossed once, right. For second one, sample space s equals to when a die is thrown or rolling a die, we have total 6 possible outcomes. And the third one, when a coin is tossed twice, I will write here, coin tossed once, rolling a die, and here H H H T T H T T. So what we have, coin is tossed twice, right. So it is nothing but sample space. So now events. Next heading is events here. Let's see what is an event in a probability. An event E, it is denoted by E, right. Event is usually denoted by capital E. An event E is a subset of the sample space. Yes, an event E is a subset of sample space. Yes, if the outcome of an experiment, if the outcome of an experiment is an element of E, we say that, what we say that here, we say that the event E is occurred. The event E has occurred, right. So an event consisting of a single point of yes is called a simple or elementary event, right? Elementary event, otherwise it is called compound event. Otherwise it is called compound event. So event is nothing but here an event E is subset of a sample space S. See, it is important. An event is subset of the sample space yes. E is a subset of yes, right? So you can write subsets. Usually here events are what? Subsets of yes, where if the outcomes of an experiment is an element of E, we say that event E has occurred. So simply the outcome of an experiment is an element, single element. So then we can say that the event E has occurred. So again, an event consisting of a single point of S is called simple or elementary event. Otherwise, it is called compound event. So let's say in a random experiment, an element of a sample space must occur, and hence it is called a sure or certain event and an empty set. It is called impossible event since an element of a sample space cannot occur. So let's see an example based on this. For example, in tossing a coin, what we get a sample space here. When a coin is tossed once, we have two possible outcomes, that is h comma t, that is head or tail. So if we designate, if we designate E equals to h, E equals to h, that is the coin falling head upper, the coin falling head upper, then E is what? It is a simple event as it contains single point. एक ही एलिमेंट है उसके अंदर, सो उसे क्या बोल सकते हैं हम? इवेंट बोल सकते हैं, राइट? सो एंड अगेन इट इज अ सबसेट ऑफ यस, राइट? So it is what we call as a simple event as it contains single point h which belongs to what? The sample space. Yes, similarly it is f equals to t is a simple event, right? So event, what we have, E equals to h, it's a simple event. Similarly event f we are taking, it is also event, it is also simple event. Single element is there, single point is there. So next one more example, we'll take second one. In throwing a die, sample space yes equals to what we get? 1 2 3 4 5 6. So if we designate E equals to 1, that is the die falling with its one dot uppermost, right? So then E is what? E is event, whereas F equals to 1 3 5 and G equals to 2 4 we are taking are what? Are compound events. More than one element if it consists in an event, so we can say it is a compound event. Otherwise only a single element is there, then we can say it is simple event, right? So let's see here what we have. 1 2 1 3 5 and 2 4 are the compound events, as they contain more than one single point, right? So here 2 points we have, here 3 points we have. So for that reason, what we call it as compound events. So only single element is there, so we can say it is simple event, right? So next, algebra of events. Next heading is algebra of events. So we have seen that an event A itself is a set, and therefore events can be expressed in the form of algebra of sets. And conversely, let's see, by using the set of operation also, an event in the sample spaces we can obtain other event in S. So let's see first one. A union B is the event either A or B or both. That is A union B, which is equals to omega. Omega belongs to A or omega belongs to B, which is nothing but event A or B. Event A or B algebra, that is union section. We are using sets here. By using a set of operations on event in the sample space S, we have obtained other events in S. So A and B are the events in the sample spaces. Then we are writing here A union B is the event either A or B or both. That is A union B equals to omega, that is belongs to A, or omega belongs to B. We can write it as event A or event B. Next, second one, A intersection B. A intersection B is the event both A and B. That is A intersection B, which is equals to W such that W belongs to A and W belongs to B, which is equals to event A and B. Let's see, observe here, and we are taking here or is the right, A and B. So which is equals to event AB. Event AB we can write A and B, AB. Intersection, what it indicates, it's and indicates, right? So these are the events here. We can write it as in the form of set. So next, third one, A is the event A dash, sorry, A dash is what? A dash is the event not A, right? That is A dash, which is equals to omega such that omega belongs to S and omega does not belongs to A, which is equals to S difference A. What you have studied in the set chapter. Similarly here also we are using operations of set. A dash is nothing but not A. So here the event not A is called, here the event not A is called complement of A and also denoted by A bar. Next, fourth one, A difference B is the event that is A but not B. That is nothing but A difference B, which is equals to omega such that omega belongs to A, omega does not belongs to B. So here what we have, omega such that omega belongs to B dash, or we can write A intersection B dash. So A difference B means the element belongs to A but not B. So omega belongs to A but omega does not belongs to B dash. Omega does not belongs to B but omega belongs to B dash. So for that reason we can write A intersection B dash. The element belongs to A and the element belongs to B dash. Therefore there is a common element between A intersection B dash is nothing but A only. So these are the algebra of events, right? So next, mutually exclusive event. Next, mutually exclusive events. So two events A and B are said to be two events A and B are said to be mutually exclusive if the set corresponding to if set corresponding to events A and B are disjoint. That is nothing but if A intersection B, which is equals to phi, so two events are A and B are said to be mutually exclusive if the set corresponding to the event A and B are disjoint. That is nothing but if A intersection B equals to what we have phi, then we can say it is mutually exclusive event. In other words, both event A and B cannot occur simultaneously. So in other words, we can say, in other words, both event A and B cannot occur simultaneously, right? For example, let's see, in throwing a die, we have a sample space. It is denoted by S. That is 1, 2, 3, 4, 5, 6. So if we designate the event A equals to 3 and event B equals to 5, then A and B are what? Mutually exclusive. Mutually exclusive, as a die cannot fall with its 3 and 5 dots uppermost simultaneously, right? So we cannot get a die at a time uppermost 3 as well as 5. So 3 and 5 are what here? They are mutually exclusive. Got it? So next one, exhaustive event. Exhaustive event. So let's see, exhaustive event. Two events, two events, A and B are said to be exhaustive if the union of the union of the set corresponding to event A and B is the sample space. Yes, that is nothing but if A union B equals to what? Yes, which is nothing but our exhaustive event. In other words, we can say in other words, we can say either of the event A, either of event A or B occurs in any trial or experiment. In any trial or experiment. In general, we can say if A1, A2, so on An or n events of sample space S, sample space S, and if A1 union A, union A3, so on up to An, we can write union I equals to 1 to n, A which is equals to S. So it is in general we can write here exhaustive means A union B equals to S. In general we can take n events or n sample space S, then A1 union, A2 union, A3 so on up to n, we can write it as union I equals to 1 to n A, which is equals to the sample space S, which is nothing but our exhaustive event. So the next heading is mutually exclusive and exhaustive event. Mutually exclusive and exhaustive event. So let's see. Two events A and B are said to be two events A and B are said to be mutually exclusive and exhaustive mutually exclusive and exhaustive if sets corresponding to A and B are such that they are disjoint they are disjoint and their union is the sample space. Yes, right? That is, if A intersection B equals to phi and A union B equals to yes, which is nothing but already we know A intersection B equals to phi, it is mutually exclusive, and A union B, which is equals to exhaustive event. So two events A and B are said to be mutually exclusive and exhaustive if sets corresponding to A and B are such that they are disjoint, means this one, and their union is a sample space. Yes, this one, right? So it is mutually exclusive and exhaustive event. So in general, already you know even it is so on up to n are the events of a sample space. Yes. So if I intersection aj equals to phi for I is not equals to j. For example, let's see in tossing a coin, getting head or tail are two mutually exclusive and exhaustive events. So tossing a coin, getting head or tail are two mutually exclusive or exhaustive events. So here mutually exclusive means what we have, A intersection B equals to phi. So tossing a coin, getting head or tail. Head or tail, if you take event A, get head, event B, get tail. Head or tail. So what do you get here? HE intersection T is equals to phi only. So similarly in throwing a die, getting an even dots or odd dots uppermost are two mutually exclusive and exhaustive event only, right? So this is nothing but mutually exclusive and exhaustive example. So next class we can see axiomatic approach to probability.